looking forward to meet many top.
This is a great opportunity for engineers from around the world and get cutting and attend all this.
The best discuss from official to that we make will set a standard for fundamental science. This will be a very essential to the whole subject of fundamental that will be to all human.
从古至今，已知科学家基统治的边界与疆域，这是基础聚会，这是一场顶尖的智慧交，让我们以基础科学之光点的未来。千额度，观测天象，探问宇宙，基础科学由此萌芽，照亮蒙昧。万物之理，数为基础，何为工程为本？以思考做的人，物理学掌握基于信息科学机理的一成为基础科学托举无数希，推动人类文明走向下一次质的时代之交。风雨朔玉流金，聚会其群贤毕是基础科学领域的重大即科学家给予探索之精彩，并成刊科学大人生为之。教育信息科学三大基础科学领域，由顶尖科学家研讨世界学问，追寻前沿科技之深邃，国界与文化的差异，大国探索基础科学大会颁发基础科学终身科学奖。菲尔兹奖等。
1, 2, 3, 4, 5. 1, 2, 3. Yes. Good. שמעת? זה רציני? הוול סטריט ג'ורנל פרסם את זה, אני מניח שיש שם מקורות. הסכום נשמע פנטסטי. 23 מיליארד. זו הקנייה הכי גדולה, כי הקודמת הייתה מיליארד. גוגל זה ברור. זה יותר ספציפי.
ברמה שלי אני כבר לא אומר. אני distinguished scientist. בלי שאומרים פלספי.
צריכים אותך להיות מנהל.
סיימתי אותו.
You must be protected. Since this IC is very popular and widely used in our to protect our data or shift things. So, cryptography also got the in addition to the Turing Award last week, Wolf Prize in mathematics contribution to mathematics. Professor in the 1952 in the with most senior computer scientists globally and the top field of information encryption and decryption. As the development of artificial intelligence and teaching, Professor Samuel also acted artificial intelligence. So we will get correct analytic traction.
Good afternoon, everyone. Can you hear me? Yes. So it's my pleasure to be here second time at ICBS and to So in the last few years, I've been that all computer scientists should be machine learning. So I have areas which are open, and I'm going to describe today my research, which had just been presented a month ago at A3-2-102, and this with a large group of collaborators from the Emirates. And this is a thing that so far the joint paper, early scientists and but so I mean secrets here. If companies train deep neural networks in order to achieve all kinds of tasks, and after companies spend so on the training, in many cases, to the model that they trained, the parameters inside, you are allowed to act as a black box, give it another input, and you get an output. The question is, this allows to interact with a black box in a deep neural network is dangerous or not dangerous, of whether an adversary can extract all the network or not. For those few of you who haven't seen a very short introduction, mostly linear elements, simplest piecewise linear which function this is a function from one real valued input to output. If the input was negative, and if the input is positive, the output is the same. So it just bends the line of nonlinearity in the whole network. And to build a deep neural network, the simplest we can solve the problem, complicate networks, but for the on we have a bunch of inputs which are each one real value, a number from minus infinity to plus infinity. Then you have an affine mapping, linear mapping plus some constant term linear. And then, so there is some linear mixing is in an action of non-negative values coming out of. And then you have another affine layer. Everything together, you go through and you have a certain number of a number of vectors, not the same dimension as the input. And for you, in order, this number the probability that the input image was a dog, and this is that it was an airplane, and so on and so on. And your class is the highest number in these abilities. Any questions about how I think that you all know this? networks are defined by their structure. Layers there are. Neurons by the biases. Like every term that you are adding to the whole linear mapping. Question I'm going to pose is it to extract or interpret? Think about it any way you want. All the internal ways when you are given this as a black box, freely interact with the questions. Decide what are the measures in space and in height. Long going till you go select all the weights, and the model is one allowed to ask questions. Adaptive is you choose the first query, you get the answer. You are allowed to choose the answer for the second query. And choose your queries. So this is the following. You evaluate the black box function DNA, and you get the first output V. Then you choose another input x2, second vector v2, queries. And equations is two values. And equations in which I'm trying to solve for xi are the used, so they are actually known. What I'm solving is for the internal parameters, coefficients, and the biases inside. The i's and vi's are known by the attacker. So if a system network linearity is the once you get into deep neural network with many layers, the mapping from input to output becomes mind-boggling. It's very, very difficult to write down to understand exactly what is the relationship between it's a cat or an airplane. Now, more than 30 years. With his student Avram Blum, now a well-known expert in machine learning, they showed the first result, the first comment about the problem, and they showed very similar to what I stated, is NP chance of getting fully polynomial time. The model was different. Their models are by someone given to the attacker his own questions. He's not allowed to work even pairs of input. You can encode and fully choosing what are the input you express. It's a problem in this complexity result. The model was also very, very restricted. The question which was shown to be NP complete is that can there be very simple 3 neuron, only this structure is allowed, which when given a particular input, it's not exactly and also shown not exist. Use decision problems, namely they use the sign function. If the input was negative, instead of input was always -1, and if the input was positive, but this was not the big. Any questions about this early problem? But it's interesting. A year later, when a very famous one, and list, he published a paper from a mathematical group about reconstructing a neural network from its output, and there he again considered a different problem. Interested at all in complexity theory, how difficult is the question. If I is of a deep, does it in the internal structure? Very carefully input out determined up to certain internal symmetries. I'm going to describe exactly. So he characterized to what extent the parameters of output behavior. And the answer it is uniquely defined. So we have parameters by say if it's polynomial number, them, etc. Characterized you didn't for activation function starts at 0 and then slowly increases towards 1, rises at 1. So it's a continuous differentiable function from analysis in order to show his result. About ReLU, which is very different. I'm not going to describe. The result, previous result, the following Pepperman. So the best was published at Crypto 2020. Again, cryptographers are involved, and Carlini, who is one of the best researchers dealing with security, he published many and for example, against adversarial attacks. Again, Miron abstracted all the weights from the network, but it requires a polynomials and exponential amount of time to process the answers. Determined there, so we needed exercitabilities, and for his exponential, this was number of polynomial. And whenever I say polynomial or exponential, it's a function of the network. So for their attack to complete exponential amount of time, possible combinations of signs. Basically, they're ReLU thing. Which poses the input space, then the system becomes much easier. You don't have the nonlinearity. You either have zero or you replace the output by the input, and therefore the problem becomes much easier. This is the historical part. The problem of extracting networks. Any questions? Yes. Our paper assumption that we know the architecture. In reality, we don't need it. We have expanded techniques that will determine how many layers and how many neurons per layer. I'm going to describe to you the simplest version to make the top. Other questions? Yes. Can attack other type. I cannot attack the sigmoid function. Sigmoid function is too difficult. For a reason you'll see in a moment. Every piecewise linear I can break. Other? Architect. Imagine vanilla connected easier, but it's not really needed for the attack. So, Karlini, Jagielski, and Mironov included that they could really extract all to the exponential running time. Their attack on toy example, which is easy to extract, data neurons and layer neurons, even though it was exponential time. For new result, I will show how to extract all the weights using polynomial number of queries and a polynomial amount of time. And our attack follows several new that completes the polynomial time. And adding our differential between and block. So I'm going to explain it in the next slide, but I just want to mention theoretical attack. We took real life, we took network with 200 neurons in each one of the 2 million parameters. It's on a computer, United Arab Emirates Institute. So you need a good computer, but then you can solve it in a practical way, even real life. And the already required 2 to the 256, totally impossible. I assume that there are deep neural networks, fully architecture, real 100% operating number. You size number, subtract the multiply, divide in unit of time. In our demonstrated attack, we use 6, so We don't need infinite precision. The function here is just so I'll not have to work error propagation, etc. And I'm making is absolute. That's only the network. You use bit training on the close relationship between deep the problem of extracting from deep neural net cipher, and for those who haven't an example how AES, advanced encryption. So here, instead of having in a bunch and or even all here bit quantity which we call substitution box or S box. Then it maps 8 nonlinear way into 8-bit output, 8 from here, 8-bit from here, etc. Goes through a net until you get a vector if you look at it, you have inputs in both cases. You have layers of linear, nonlinear. All the nonlinearity, we know ReLU, everyone operates boxes, everyone knows. The designer of the crypto system. First, the secret key are so it's here the unknowns in this problem, the weights and biases in the linear. So it looks almost the same. Yes. Vibration in the room. There are going to be some, you'll see it later. Any questions? This tests how to break block ciphers, which is this can be used in order to deflect their secrets. Okay, I already said all of this. Talk a little bit about symmetries of uniquely determining because there are some of the parameters behavior at all. For example, if there are neurons in the first layer, you just coefficients in the next layer to follow the value in the previous layer, and the network will be exactly. If you look at the weights, the first will look different, but it just moves in the first layer. So changing the tree, which does not change or find correct order. Similarly, the inputs, the same vector of coefficients, I can neurons into one new neuron by linearity. So there are things like this, but there's one linearity, which one kind of of it will be important in the rest of the talk related to the fact here, but there is a positive. I mean by that I say on this linear mapping change simultaneously all the coefficients by multiplying all of them, for example, by 5. Suppose that I multiply all the coefficient term is multiplied by 5. Only the coefficient of the x of the input term is constant. We are mixing with all the input happens when if the input was negative, it was 0, remains 0. 0 is 5 times 0. If it was positive, then I multiply the input by 5. The output is multiplied. And therefore, the multiplicativity by 5 linearity. So it is by positive. Remember to say 5 output was multiplied. Every neuron should divide its coefficients using this value 1/5, and then the output of them go back to the same as the originally. Parameters in one layer and compensate next layer. What happens if I multiply not by gun? Why? By -5 of the linear mapping is, but this flip I was on from being positive to being negative, from being negative to being positive, and then the output is not 5 times it used to be. Okay? But I'm not doing. Okay, it's positive. Multiplex. View of the covers layer after layer in the same way, breaking a crypto system with first right layer. Once we find everything, peel it off by original mapping into an image. You already assume that the number of neurons is smaller, and if you are them, all the output going to keep. All the head may simplify the attack necessary to be able to n inputs and the output, analyze it very carefully. Into define point in the input space, defining a critical point, sum all the is just equal to 0. Move around, is going to be or vice versa. So this is of the network suddenly change numbering sides. Nonlinear. Now critical value flips. In that vicinity, I can replace either the function in a composition of linear. No, I have affine behavior. I'm switching from one affine across to the other side. The zero started being identical. Very starting to look. Assume it's a two-dimensional input space. An input vector into nothing to do with it. Be an image from the internet. Between values precise, which I'm going to call T, 0 and 1, and demonstrate vector and 1 minus T, so multiplied by T, to 1. My image, the image. Now it's a function input into 1 out T, where it is the output. Now for me to look at one output, it tells me while at a certain cell, once the shape of this function. This is the graph. Going to be piecewise. For example, we start at unlike point. I'm reaching is switching currently mapping. And those points behavior FN behavior then move to cell in. So it was in region I was 11 and then represent a straight. Looking at I catch there was a break, and there was a break at which a ReLU equal to side generation in the crypto system. Something you access output. So that exactly 0. I change the. This is what I'm going to use. Explain. Which is this clear breaks. I'll in the question. One image of a once, and I bring a dog through one is sharing going now locate layer already saw previous layer is layer which is unknown, and then later to the current layers with linear equation in terms of y to the ReLU 0, the output of the before. Find functions, but then I'll find single element, big picture. Okay, now x0 I'm going through which I don't know anything about. Stage input function flip with value of the ReLU in the output effect that I will have 3 point is linear is going to be so going to break down and then go very important. Are going on this and not by the from so it's very careful, but the x coordinate effect that the input new late is going to the value. Of course, there could be break to exactly the same. It will by like now that break point. I'm going to 0 and random another range in example. You know, if I in the out the determine by the in the 0. This will this is a little bit about myself. Lucky because they like all this. Okay, so now we're the is the following. I told you that of course I could if I could multiply it by 0 of them to have exactly divided I'll compare done sized vector C1 assumption 0 C. Let's assume that this C up to C1 normalized of the neuron. I cannot find this, but if minus 1 ratio of values, and if all the values 1 values remain low, if I lost when I go in the signature, there's one range which I can easily do, multiply by 5 or 7 or any positive constant, and I'll just I want, and it will be compensated for in the next layer. The next layer will be automatically giving values to constant. But the presenter I should add minus 1 because for the signature by minus 1 totally positive to negative things which are unimportant constant I multiply that the main reason in 2020 couldn't, because they couldn't whether I'm going to show you how to do it. Good. Now I'm going to show how to find the signature. Applied by positive time the signature. These are the ratio at a critical point in the input space. In the first coordinate of that neuron, distance from the time is going to criticality. I point coordinate. criticality that I again ratio between this size. I'm hiding under the idea find moving out of criticality. And you know that is the this point current time in what may happen due neuronality in later neurons. I have to then the critical neuron, the earlier, so I could calculate one neuron being 0 now, the point of criticality. Because I know the you to know from earlier. I still have to distinguish whether or future. What we all this when what in the which is not layer. Function later because I assume layer inputs neuron, the neuron looks totally for signature, but it's a wrong, it's not new. So number of traversals, points, cat and dog. They connect them in pairs. It changes of for each one like a signature. All that so know that to an error that I don't recognize because and therefore then the map to input of that neuron is correct. Yes, no, if a sequence in the and when you infinitely precise now, it's convect to be to random point. I'm not finite goals with inputs. Numbers likely to see the same signature occurring twice. Solve most of the problem. Right there. Correct. Doing my concentrate only and I do, hence I'll identify all the sequence with the picture and neurons. If I don't, I don't really need. The problem now find my signal multiplied by when I look only at, so I'll move to the side of the output. So the output is down up. Then go whether the positive to negative side or negative side. Now, here, a wiggling technique. This is I'm a particular. I'm choosing change maximize. So this I have a vector in R to check, but what I try to achieve in R to the n. My way in this back and forth show they will to hold the to we expected in my input. So the question, if it was like then of course coefficient I can change my anyway I possible action is between the direction and the vector is of course then moving not at all. Then it's going to be goal take is in this to a small change choose any direction you'll get possible change. What happens space? Probability it back in random direct is going to be almost zero because you are going the same amount. So input function knowing coefficient. So then that one. But the maximum vector times. I'll just wiggle animation by the change in the input to this section known coefficient goes in direction doesn't only so which strongly happens some effect on the input correlate the coefficients, then it's going to be very small. The other wiggle the way going back and okay. You have to think that I'm going positive negative mapping which through the input on the 5 I want the point minus if the output you get 0 4 and once the thing wiggles clear including the and through to be visible with analysis of the weak you might just be here is 1 point particular ReLU switched different in this here ReLU so and this is another pitching about the being the size don't multiply by C1 it's tied to free value of the coefficient minus. So now I've made the move on average on the version I experiment and I correct to results. So this is all the parameter player of the first the chair coefficient. 65 minus is where the wiggling on the clearly decision neuron is even more sign was 0 and 200 real plus basically after cooling of the neuron. The element in this polynomial is the answers in a polynomial ability. Ability is, but it's all polynomial. And by solve requires 6 times.
The professor, very good talk. You did Professor Yao. So now, so and questions.
So about the of coefficients much larger. So they make size 10 or size divided, and this unit precision with demonstration was accuracy of the layer points to the measure of Bitcoin. Every additional layer is the accuracy. It is smoothness. Yes. Using 60 moved by total and all multiply 60 but for everything, this, etc. Simply to
dot product between two runners. Average 1 over x.
well, this is what I n is the analysis for the dot is an unit amount. So this is visible in the and changes on the next other neuron now trying to attack the change of zero of the change in one and the other case is it is when one is leading no time. Thank you. We can actually parameters.
Understand this.
And
用擦耳横星云激动仅昧界
not all. I'm about network. I am
本部的人类对于学家力量领域信息科学家下令我是为突厥文风云过经其与的主为探索与合作科学环绕理论计算信息科学情全研讨之大流计之国典国际学术海一展之深成就讲是等奖项等品。 任委员会主席。学子照评基础科奖爱研探索未知。
还是有板书之类的。这个是麦放在兜里。这个好，你对对。好好。这是软件。这很准。然后7月15号。你好。你好，哎。好。哦。这个。好，回翻好，需要。好，行。
穹苍广阴探问宇宙科学照两蒙一方万物，物理学家不可思议的能与信息学及推理的力。
Good.
Thinking test. A distinguished professor at the National and Center Action Storage Association. I obtained his PhD. Frequently worked. He professor Dr. General Professor Andrew.
Okay. Thank you for thank you of the appreciate and okay to be however awarding the paper is mainly in current city unit. I moved to this paper H19 unit. This is simply use very material on the simple. We know forming by river artificial atom or among this definition of metamolecule than the force. Discrete materials principle. So you interaction of plane wave metric light goes plane where it's near refraction median and the river some feed the interface construction of the control interface of so-called A3 so in in the 20, they are this in the surface. Different. And this phase of the so if you can control you axis in the or length and reason to make additional length make very good length, a lot of length together. It's very bulky, can make artificial focus. Like you are by people into of narrow and frequency. This to focus together to make have to this and show the spot. This is the way have to see everything. Show eyes. People this issue use red to focus demonstration antenna. Continue wavelength. So challenge for people. That's primary. So challenge in the 20. So they ask this three and you it's input. You know, put it. You should be okay. The principle you can do it is like data and you put in order to also people have some for example to learn and this way balance or for you have dim put to make So the and about all the material, the artificial molecule with those not by nature. That's otherwise so maybe they have index of which is related to the and or nickel you made. What kind of is made? It's also a dielectric materials and in all kinds of material you have to do some simulation program you made by yourself where limited and then you have to and transmission and find out the efficient wave. Then so have to this different which demand you have about this is how to make it if with the pack arrangement so made those micro electronics some new or to make it and whether it's work. Basically you can collect the view to do the arrangement of different bureau to one narrow contain the oscillate to pi make it we oscillation and then go to this sandwich the EM wave mirror on the side this current magnetic dipole. So they have oscillation and then to the magnetic to force a phase. Your electric occurs rotation to pi. So you also measure between size the narrow antenna. They can go to okay. So they are ever we take the convention have this polarization part data. We also the lens basically is in the center. The light goes to the edge. We actually make the edge fusion align the higher in the case. And also the geometric phase part for the phase compensation, we can make with a different curve and the one and reduce the maximum. In this way, whole arrangement lengths are in the easiest the best way. Okay, then I want to talk about resonance. This is the integrated resonance unit 1 and 2. This work on we'll see it been one guy post or keep doesn't work. For example, the head you hit the then you know you listen. Chinese medicine they give and they and third day they give you or this like things together. So case they it's the piece they actually medicine different medicine. So that's reduce this into that means what for example of this medicine 50 micro and then the base have corresponding to the 300 16A, they have meters. 4 nanometer times those two. Type of antenna gap is here is narrow, and all of them are idea of integration, and we see center symmetry. Okay, circular symmetry. And then you can put together equal to all to make this his refraction length. Also have the gases like my gas narrow sensitive like cavity, and we rotate it with the for of the propagation. This is this kind of a picture. This is 15 diameter, the center part, and narrow. Then this is angle. It's 800 nanometer. All different at different inside and different circular similar to do it. Okay, and so to continue the visible basically for me. Okay, impedance will go wavelength is focusing. Okay, first time image trace the first time. That's the paper they like see they demonstrate if I can then the and then the material may change outcome, and this theory can have a purpose. So, in 2012, they have a postdoc antenna. The antenna of the server. This is the light reflected more than 1,000 times. A paper viewed of the and then the time full color image. Also, we make the layers of the city to make different and continue and which material and also NAPO. NAPO you check type action it in the way, so they cancel each other. We also full color. We make the surface. We reveal all the phone headers. Currently has and in front of the RGB side is only, but the silicon sensor they have the light control only to their header comes in and all not waste a lot of in way camera. They waste the light. All the light comes in. They write or imaging. Example in make important see the info just print the different angles they collect into this. So this is a demonstration of 5 years. You can see not this one system for doing the meta. Can for example 600 nanometer wavelength. Okay, generate the 800 nanometer. 3 depends on its signal light, and then they like focus our spatial we test waves. Hot is 190 meters. The minute the is vacuum. You say what's the vacuum? Okay, we use the infrared. We don't skin cancer UV light from 200 meters. UV below 200 nanometer light, the vacuum has to be detected. Its energy is too high. Air or difficulty. This light will we host hydrogen have to be for the vacuum UV light. This saga for the semiconductor in consider how to do it. So and also we make this because our lens last years people make really cheap, but small lens. But now this lens is so small. This is you know the intestine vivid on the intestine 小老肠子里面的 this big poor sad okay actually anyway this is a challenge. So we catch fly back because I have to I think I will move to and I see we have acoustic and it's and we have good for John Pendry and we actually we have in the CTU so and scientists and students are going to stop and talk.
For the training
Depends on the from first the material. Okay, material can form the different narrow antenna. Okay, metal or semiconductor and different plastic or focus so narrow in 3D printing, or there are many ways. So basically it has to be from 0 to 2 pi to for fully narrowest, and then the answer. Yeah. Yes. Harmonic and efficiency is very for traditional nonlinear atom and the molecule in this only had or narrow molecules very challenging to make high. So make it, but compared to one, so that's what the surface we make the focus to make it feasible. Still, say we do right still there.
Okay. So are there each small lens or small lens? You're very small. So
Yes.
How do you handle the appearance?
Okay. So that we made basically through the in the them you don't see the discrete of those knows the difference. It's not diffraction. It's optics is that's compared to our
Okay. Yeah. So if not, that's another round of
Thank you.
Oh, okay. Okay.
黑洞学此类物质理基础 学好的认知，以智慧，让我们理家赋予机器人是以基础化到说去怀柔眼睛为钢琴与家重塑探索，在丘城同向精神人生数理论计算机科学三基础高尖科研讨世界学问之大流，追寻前沿科技知识，跨越国界与文化的差异，搭建国际平台，探索发展之未来。大会颁发及申请世界多国院及奖组成评审。生喜映时刻科学层和创业的重要价之路，指引方向，未知世界。
Andrei who have worked and they will be preserved for their recognition.
Congress of Beijing politicians had success.
Event here, I myself also to meet researchers,
mathematicians, physicists from around the world to come and get together to cutting-edge ideas. I'm looking forward to attend all this.
There to discuss or benefit.
We're running a talk for running a bit late. So the speaker is Professor Yehua, graduate director of statistics and probability, Michigan State University. Research interests are statistical genetics, statistical analysis. I hope the analysis mixture and balance. And he has journals in addition to
all right. Very much for coming to this session. To invite me, great honor. My first place and of this beautiful campus, mountains in the mountains area. So I live in Michigan. Michigan is really flat, So we have a little 100 meters high. We call that small, really little. Inference with Mandela joined student. Student is graduate 2 years, and also Stephen Burgess. So I want to start with many years of so this is supplement you is a risk. This is the effect, and actually a longitudinal study shows there is no effect on CHD. RCT standard for cost. Standard is RCT, randomized controlled trial. A lot of the confounding factors at the end of the study, then you can compare different groups, control group, then you can establish a example vitamin A and so why study taking those supplement reduces some of the disease by the acting in the art. So it turns out that if you not the really risk factors, alcohol intake, those observable, observe those, but a lot of, and how to measure, we can measure those. So and so you can some of so the really the patient to relationship and for disease on the heart reduce, but if you're not controlling compound E founders culture and correlation possession, we all know that, right? So you have a strong correlation, but that's not really implying. So the only way when you establish causation is have to control those confounding factors. So factors, those are observable regression. You can picture it as a covariate factor. But if you don't have this, and then we need to tools to do the for RC randomize it, exposure group. So you get the end of the difference of those to or some other ratio or some other measure. But there's is not always ethical or practically toxic. So it can be very expensive. And so there is still a need for time we collect, not really random, collect, taking the measure, okay. Those are not. So when for weighting, and people score to the propensity score measure, so the probability give covert propensity and use the propensity score to do the matching or stratification, do the inverse and to framework that direction. There is no to confound it. You have to unobserved. So one studied for a long time. This is quite popular tools in econometrics to study if you have a government has any causal concept. So what is the IV regression? So there are three assumptions to find the IV. This is the so we're interested in exposure Y and X, Y as saying so what the need to as a valid. So the first has to be associated with X. So Z X only through so can affect. So there is another. The diagram is very similar to the median. So the median is Z or X as and also Z. Also can affect Y only not through us or other ways. So affect Y too. There's not. Assumption is to be independent. It's not really. It's under this confound. So there's more you see and Z effect on Y. All right, so Z as the instrument, and then this is a very popular model, structure model called the 2C. You do this regression and get an X hat and this hat. Get an estimate and you can see Y, so the projection matrix. Know the Z in U and the V. Both U and there's a factor X not. So the course confounding, okay? U and X, and X hat and Z is independent. And then you can use that project to get the effect. Okay. But the challenge is to IV causality. Okay. Of the MR analysis in many areas. Recently, you can see the MR analysis and so and MR. So some Mendel's and independent and the side-by-side MR and the random for R and segregation of the two alleles. And then expose the functional alleles. So we have two groups studied, and because this is the independent source segregation, is randomized. And here's the example. For exposure group, control groups, and non-smokers. And that non-smoker, we have two groups or now have two groups mimic. MR frameworks, visual level data with the black effect, visual level data. Yeah. Example issue relationship. Answer accept DNA to apply the issue with action bias because and there's a bias, a lot of SNPs there, and that leading to the weak IV bias. Okay. And we proposed to address our MR split. Work is based on this is MR. So we have two GWAS. Okay. Which another one and outcome I get the so beta X for given effect. Just clear those causal effect. First, access the data. So these are so you can download it anywhere. A lot of ones the statistics available. Info and difficult to do sensitivity level. Also, for us, these pointed out the total not the so the limitation for this is the two sample popular because there the data they're big consortium and you can data do the analysis. That's why their analysis people do the two questions. Why you do this? Do the and people are so you analyze approach the outcome, but they're not directly of these two. So there's an for the risk. Yeah, people are using that, and so there's white. And you do that. So yeah, but they don't really care. So papers in particular review method and rise our approach. We focus on the one sample per individual. So even on the one sample MR analysis, some of the bias issues with IV selection bias, the problem. So you have to select IVs. And there is by sample split. We use one sample to select IV, another sample, do the effect to estimate. Question. So proportion. Essentially, we use effect estimate. Similar the Bible. And weak IV bias, estimate our bias, and with MR split, so it's and it was bias issue IV. Okay, these two stage square and many even these. So if you have many IVs square estimate is not a consistent solution. Is find all those IVs to form approach 2-year plus computational called allele score genetic risk prediction here. There's 5, and the leading thing is you have a smaller variance. So we know this is a bias in the variance. And the number of alibis, so we have a larger bias variance that it can affect your testing power, larger variance testing power. It proposes MR to address both types with bias with bio. Is in the and this is another with I work with motivated. CFM use an idea. So as an example. Use these and use the data in I2 from 1 as G2. And use I2, they select the IV. Once they select the IV, then you and G1 tilde, they combine G together, and then eventually do the cause inference. But the problem is approach the strong from 1 IV. The bias is small, but it's actually that will show you. And this lead to the small bias and in 2 paper published in International Journal of Epidemiology, this work evaluated the different ways for multiplying. This is to multiply get a small compared to multiply. You have a major IV, so but they just mentioned this report address. They think this is a good way to solve this. Our work is motivated by this. So split a random set I1 and I major for major IVs. So we use statistic to define threshold. For the weak IVs and the I2 data, weak IVs to form will leave those major. And we do the regression with the and get a pretty in this. Use this side major weak and the x1 hat to the x1 x2 together this x hat. We do a regression of x hat with 1 and then beta hat. So our approach is different. Combine the G's combine the major IVs, the I drives and 2 can be different. Now, this cannot really, but with the we to do the causal estimates. And this is the comparison with the 2-stage Limo rules. Point 1 is low confounding, and point 2 is high confounding. And you can see this is the SNP heritability, the effect of the and the square Limo. And this is the acid to siliceous, and these are an MR split. We evaluate variant the sample our estimated estimate effect. So small. The power for another group split. You split one sample and need to do multiples. And so we propose many splits. Better, right? Many more into so it's estimate of the causal effect, right? And use the p-value, this aggregated p-value is defined. Simple approach of, and this is a multiple split and time, and this is a type of error. When the top in the bottom and it's 1,000, 2,000, and you can increase. Split, you don't really need that many. Stable. So the sample size is small, you need more, 50, 60 samples to you split it 50 times the stable power. Okay. And for the data, so function is measured by R, and so low EJ indicates the impaired. The goal is the relationship at hypertension. I'm not sure if you heard about this. Apparent hypertension or ATR taking 3 mentions. You can so it's become resistant. Okay, so people are interested in the resistance. Has the okay. So there is a long debate and it's a binary. The binary is a non-real and the different user and try to evaluate if the sample size and we have equilibrium independent with 1,000 really small split. You can see it's small. Occasionally you get to the aggregate the p-values made out of the 50 sample is nowhere in R function. Caucher R and another data is the p-value there. Some of those are p-values, and this is the estimate. We also summarize with sample split and we study, and so the plus genetics mind we which work on this, find those impact and how I in the result. So those that third. All right, so I have some okay. There calls for causality. You can for the if there so this the compact out and the grander test longitudinal sequence over there's if you have a looks exposed come over and that kind of fact. Okay. So that's we use data to inference. So there's the department and also effect eating bingo. So and binge eat, so binge eating. In Chinese sequences getting 暴饮暴食 hypermon level. The hormone emotional eating here. So we come in and the other one get 2 is the other one called NA. These are banner score. Today, then 16 time point and so start later. Is for each measurement, so 16 point, and this is outcomes. So we prep the first stage. There is a time varying effect. And so we use a model this alpha t to estimate this alpha quadratic inference and with significant g. And so what this p and determine the effect of the and this. So for example, if p equal 1, this model reduced to this one. So q equals 0, current x2 is what the current one curious will affect really the current use one is how many outcome model Q. This in the GRSSB approach to select the series is Q. I will not talk the next. Then so this is the use information point. Okay, and after the point of the estimation and inference 0. Okay, table tests the number of p's. So p is 1 or 2, right? If it's a p is 1, you only have 1. But if it's you have 2 sets back statistic. It's beta r t final statistic, and it turns out the S is okay. And the variance covariance. Distribution for global is a mixture of chi-square, and this mixture of chi-square is weighted by using the simulation. The p-value for n exposes previous current is time lagged 2 time points. So come and size to 400, so the power significant significant. So result, and this is the there is a cause PRO, progesterone hormone EQ, and so with 2 Q equals 0, that means previous exposure, the 2 exposure has a causal effect on the. Okay, so these are the two estimated. This is the estimated beta 2. This is a confidence band, and these are point of confidence band, not simultaneous confidence band. And for 402, for the P is not significant. So this hormone on this, but for DBQ has a causal effect. Has no causal effect. No causal effect on these two measurements. So only the DBQ measurement. So so looks like causal effect at the early stage. That's over here. It's the middle for beta 1. So the middle is significant because the confidence band cover significant end of the over here in this stage. And for the effect, beta 2 weaker than the beta 1. That makes sense, right? So current exposure has a strong current outcome compared to the previous exposure. And these are over here significant because confidence band does not, and maybe a little bit over here, and at the end of the cycle. So for the beta 2, but not for beta 2. All right. So, examples convince you the power of MR analysis for MR split size and weak IV. This longitudinal model for MR analysis, and with a longitudinal MR analysis, we can understand the two other models. Well, the other one is the cumulative causal effect model. Time to show, and we delayed the causal effect. And so the other one, I wanted to say there is a views of MR analysis. Causal chain, so IV only through X. So there is biological exposure and outcome. So and there are some publications as air pollution as exposure to infection, other disease. But think about this: PM 2.5 or air pollution, no genetic basis, right? So your DNA does not really determine air pollution, right? Does not determine pollution. So this, you can see this abuse of MR analysis. Download those data. Find some of the association air pollution, but does not fit loop. So that's something that's be cautious when you perform analysis with a causal inference. All right, so with that, I conclude my talk. And questions?
Any questions from?
Thank you. I have two basic questions of your talk. So let's first start with the later part that you had. That was very interesting because cycle in that sense from 45 to you could consider causality or the way you did it that. But typically when you don't this type of longitudinal structure, it's very difficult to find out the optimal lag because the lag, different methods gives different lags and that can create problems interpretation. In your case, it makes structure.
Right.
So I have to generalize this thing for a non-cyclic longitude. Will that be the same?
Yeah, you can still do that, but the price the time wrong, right? For y, really take any lag.
That's right.
Right. That's right. That's a limitation.
Yeah.
There is no way really you can get away from that.
Cyclic data, right? I mean,
Right,
sometimes you don't have
True. And then it really depends on if you start. If you want to equal 2, if you p equal 1 is equal to 2, you can only start with 1. Right? So p equals 3, that really reduces the number of the number of the time do the modeling with your y's. Yeah.
Your talk again, I mean, first kind of application it makes sense because you have a large data. 80 to 100. Okay for if you have that kind of high dimensional data. It's not specific to this particular application, right? It's like more general.
Right. Yeah.
So if I have like a small, like 50 or 60 different groups, use the classical methods like sometimes I apply your method.
Yeah. So we're not really splitting to two groups. Every time you randomly n sample, right? You randomly one time. Random split. Get another 2. Then you repeat these times. But each time it's two groups. With equals, right? So then you do the estimation for that groups, the p-value, get the beta s, and for that random split. And the second random, the p can get a beta estimate. Third random split is 50 times, and you aggregate to get the final p-values. Yeah. The sample size is small, and it's actually improve the robustness. Yeah.
Yeah, I have a question on the second. Did you use the instrument?
Genetics, SNPs.
So yeah, then when causal effect in the variable set ratio, right?
Right.
Where is the ratio here?
So here, if you pointwise, you get the point for fixed t. For you have this xt, then you have the beta n, just for, and that's for p equal 1, only one time. Or you can show pointwise ratio. Not doing the ratio here, we just so get the predicted. This is regular longitudinal varying coefficient model. Right, you get x hat to plug in here. You plug in here, then the second stage you have the and this is the data. Whatever data tells you what is the optimal p. Yeah.
So you okay. So at the different instrument at different t.
Different age.
Different
that's
t. or just single G? It's just a single.
Right. It's just a single G. Right.
For all.
So the now
Yeah.
G does not change over time.
Have the same G.
Right. Right.
Single
Right.
But is that possible? For example, at T on the X at the T, and next.
That's another issue, right? We consider you could have your act and
time.
That's it's possible. This is a more version of not consider that kind of the
Yeah, it's more complicated.
Yeah, it's more complicated. Yeah.
So just curious about the y. Go back to the y is so they're continuous variable. Is that right?
Yeah.
Like to use
Yeah.
Because DEQB, I think PN should be fine, but DEQB is more like phi.
Yeah.
Is that right?
You can see this one.
Usually this in the likelihood questionnaire, right?
We consider it as a continuous. Okay. So just
also yeah, because the model, if it's just like the scale from one, I don't know, like a linear model, maybe.
So we use this one as kind of we don't have other data to plug.
So actually, my question is, so how do you other than linear model, or the outcome is not continuous, like a followed, or like type outcome, like 1, 2, 3, more
for the outcome?
Yeah. Continuous variable.
I think you can do that. If the y is not really continuous, it's a little challenge part is maybe the lag selection of the lag process.
Okay.
Yeah. So it's not that trivial to apply for the lag selection. But I think still the approach is basically selection. They started with the P and the Q. So started with a large P and a Q, and gradually shrink to, and then for each P and a Q, you find this get an F statistic, AIC, to pick the and instrument for Y's. I
be info on the global test statistics.
Question. Yeah, they have the impact on testing for sure.
Okay.
Yeah.
Just it's challenge when you deal with outcome.
Yeah, that's true. True.
Yeah. Okay.
Yeah.
Thank you.
One more short question. Well, if not, then let's apply.
Thank you. Yeah.
Yeah, is A2. I will give this remark in
穹苍广多容，星黑洞冥冥，天探问宇宙，科学由此萌芽，照亮昧世。 之理，数为基础，根成为本。数学家以思考重塑了类对之，物理学家智慧让我们掌握不可思议的能力。计算机与信息科学家以赋予机器逻辑推理的使命，召开或时空时基础科学托举无数往人向下一次质的飞跃。时代之交，今聚会北京，眼期群显毕至。基础科学领域的重大进展，重塑好奇与探索之精神，优导向，秉承开精神。国际基础科学大会应大会聚焦数学、理论物理、理论计算机与新大域，邀请科学家研讨世界学问之科技之深邃，跨文化的差异，搭建学术探索基础科学发展。大会颁发基础科学中成就科学奖、世界及诺贝尔、菲尔兹奖的奖项。